In this example, we are given that a plank of mass m is placed over a cylinder of mass m as shown, and a horizontal force F is applied on the plank, and it is saying if slipping is not there at any surface, we are required to find the acceleration of plank. Now, in the solution, we can analyze the situation first. If pure rolling is there, as it is written that no slipping is there on between any surface, say the cylinder is moving at an acceleration a, and say the plank is moving at an acceleration ap. In this situation, we can easily relate the two, as for cylinder, say its angular acceleration is alpha. We can write for pure rolling, here a is equals to r alpha, and as the topmost point of contact will also not a slip, the acceleration of plank can be written as in the situation a plus r alpha, that is actually 2a. The reason is with acceleration a, the cylinder is moving and the topmost point of the cylinder is having a linear acceleration r alpha with respect to center. So the total acceleration of plank, which is equal to that of the topmost point of the cylinder, which is equal to 2a. Now, if we write the equation of motion for the two bodies, cylinder and plank, let's first analyze the direction of friction. As plank is moving in forward direction, we consider that it is experiencing a friction F1 in backward direction, and an equal and opposite friction F1 will act on cylinder also. As cylinder is moving forward, say the friction on cylinder is in backward direction F2, equal and opposite friction F2 will act on ground also. Here we can write as pure rolling is there, friction F1 and F2 we can write as a static friction. As we know, in case of no slipping, the friction is static. And if we just write the equation of motion of the two bodies, we can write for plank, in this situation we can write it F minus F1 is equals to m into acceleration of plank, which can be written as 2a. So this is our equation 1. For a cylinder we can write in forward direction it is experiencing a force F1, and in backward direction it is experiencing a force F2, so we can write F1 minus F2 is equals to ma. So this is our equation 2. For rotational motion of cylinder, we can see that both F1 and F2 are applying the torque in clockwise direction, which is the direction of its motion. So we can write the net torque on it as F1R plus F2R is equals to I alpha. So its moment of inertia I we can write as half mr square for a cylinder, and angular acceleration for pure rolling it can be written as A by R. This is your equation 3. In this situation here this R gets cancelled out. Now here if the second and third equation are added, you can see in this situation on adding second and third this F2 gets cancelled out. This will give us 2F1 is equals to 3 by 2 ma. And now from equation 1 we can write, in this equation we can write F minus friction we can substitute as 3 by 4 ma, because the value of F1 we have just now calculated. We substitute in equation 1, this equals to 2 ma. On solving we get F is equals to 11 by 4 ma. So the acceleration of a cylinder we can get here as 4F by 11 m. Now in this situation, if we find out acceleration of plank, which is required here, acceleration of plank is 2a, which can be written as 8F by 11 m. That will be the answer to this problem.